Hello students, now in this video we will start our chapter 3, that is counting principles. Chapter 3, counting principles. Let us see that. Now here in counting principle, actually it is a part of combinatorics. That combinatorics is an area of mathematics that has extensive applications, various applications in various fields such as engineering, computer science, biomedicine and operation research. Now in computer science, it plays a major role in design of computer chips, which involves consideration of possible permutation of input and output pins. Arrangement of logic gates is a basic element for computer architecture designs. Both natural and computer languages are closely related to combinatorics. The component of these languages such as sentence, paragraphs, programs and blocks are arrangement of smaller elements such as words, characters and atoms. This has a direct application in word processing databases and string searching algorithms. Permutation and combination are used for simulation in many areas such as networks, cryptology and operations research. Counting is also required to determine whether there are enough telephone numbers or internet protocols addresses to meet the demand. Combinatorics also form a basis for many games and puzzles also. The aim of this chapter is to equip you with the basic techniques of counting we have given. Now I am teaching you various examples and how to solve them using these techniques. So now basically we have to see the basics of counting in this chapter. The basics of counting are what? The addition rule, product rule for counting. Also we have to see the inclusion exclusion principle, pigeonhole principle and permutation combination. These are the things we have to look for in this chapter. So now let me start the basics of counting. This is what chapter 3. This is chapter 3 in discrete mathematics. So now first of all let us see basics of counting. Basics of counting. Now in basics of counting we have to see the addition and the product rule basically and inclusion exclusion principle. So here let me write first of all one definition, that is about the cardinality of a set. So the definition is, let S be a set, let S be a set, S be a set if there are exactly n distinct elements, if there are exactly n distinct elements, then elements in S where n is a non-negative integer. N is a non-negative integer. N is a non-negative integer. Okay. We say that if n is non-negative integer, then we say that S is finite. S is a finite set. S is a finite set, and this n is a cardinality. N is the cardinality, number of elements in that set, that is the cardinality of S. And we denote the cardinality of S by this symbol, cardinality of S. Now let me take an example here. Let A be a finite set of even positive integers. A be a finite set of even positive integers. A be a finite set of even positive integers less than 15. Then what are the elements of A? Then A is nothing but the elements with 2, 4, 6, 8, 10, 12 and 14. Therefore, it consists how many elements? 7 elements. So, cardinality of A is what? 7. Okay. Now, suppose, let me take another example. Suppose I say another example. Let S be the set of letters. S be the set of letters in the English alphabet. In the English alphabet. If S is that. Therefore, cardinality of S is what? 26. Now suppose S is a null set. Therefore, cardinality of S, that is cardinality of 5. 5 is a null set, that is what? 0. In that case, the cardinality is what? 0. Now the next part, let us see the fundamental principle of counting, that is addition rule, multiplication rule, then bijection rule, these one. So let us see them. Fundamental principle of counting. Fundamental principle of counting. So in that one we have to see these 3 rules first. So first rule is of addition rule. Now in addition rule there is a sense of or let me write or sense. Now what is it exactly? The statement of this is let an event can occur through process 1 in m ways. Process 1 in m ways and through process 2 in n ways. These n ways are non-overlapping. Let me write that thing here. These n ways are not the same one as the previous one. These should be different, non-overlapping. Then total number of ways of occurrence of an event will be how many? m plus n. Will be m plus n. This is important. See, process 1 is done by m ways. Process 2 will done by n ways. Then total number of ways of occurrence and event will be m plus n. Now for this, let me take a very simple example. Suppose there is a city A. This is what? A city. City A, and suppose here is the city B. We have to go from city A to city B. Now suppose I have, this is one roadway to go from A to B. Suppose I have another roadway to go from city A to city B. Suppose there is one more way, that is the train. Suppose this is the way of train, T for train, and this is one more, suppose airway. This is an airway. Fine. So now how many ways are there total from going to B from A? Two roadways, one train and trainway, and other one is what? Air. Or I can write here, this is what? An airway. This is what? A trainway. This is a roadway. Fine. This is road 1 or this is 2. These are different. Now process 1 by M ways means what? If we have to go by road, then how many ways? 2 ways. If we have to go by train, then 1 way. That will get added in that. This is different one. This is non-overlapping, and the airway is also the different one. So I can write here the total number of ways going to be from A. Going to be from A are how many? 4. Now from this we can say something. We can decide to notes. We can write 2 remarks here, or the notes you can say. This addition means what? Or. Either we can go by road, or we can go by train, or we can go by an air. So here this addition gives the sense of what? Or sense. So let me write the notes for this. The note for this. The first note is that addition means option. Options. Addition means options or. Addition means options or sense is there. Fine. Then the second note is that number of ways should be mutually exclusive or non-overlapping, mutually exclusive or non-overlapping, or we can say another word for the same, uncommon. These are different, uncommon. This is the important one. Either road or train or airway. These are the things. Now the second rule is of multiplication. Multiplication rule. So let us see the statement of that. What does it say? If an event E1 can occur through M ways. If an event E1 can occur through M ways, and another independent event E2 can occur, another independent event E2 can occur through what? n ways. This is independent. First one is different, second event is different, independent event, n ways. Then total number of ways, total number of ways of occurrence, total number of ways of occurrence of E1 and E2. E1 and E2 will be, how many? Will be m into what? N, a product of them. Now, let me take, now the same concept will be here. I will take, now here suppose city A, okay, here city B, and here city C. These are what? Cities. Now, suppose here again the same thing, two roadways. This is what? Roadway, road 1, fine. This is road 2, suppose. This is trainway, and this is suppose airway. Okay. Now from B to C. Now B to C, suppose this is a roadway. Suppose it is dash, we will take it different. Roadway. One roadway is there. Then one trainway. Train dash. Suppose it is first one. Another trainway, suppose. This is second one. And one airway again. One airway, suppose. Now suppose we have to determine total number of ways going to C from A via B. So total number of ways going to C from A via B. Suppose we have to go up to B and later on we have to go to C from A. So here this event E1, what is event E1? We have to go from A to B first. So event E1 will be what? Going to, or let me write from A to what? B we have to. Fine. Then and another B to C, and is there. So and means what? A product. E2. Different events are these. Here also and another independent event E2. So E2 will be from B to C. So event E1 can occur by how many ways? 4 ways. And event E2 can occur by how many ways? 4 ways. So total how many ways are there? 16 ways. So here multiplication rule has sense of what? And sense is here. Wherever multiplication rule, so there will be a sense of and. Suppose I have a question, number of ways of living B. So to leave B, now here to go to this side there are 4 ways, and to go to this side there are 4 ways. Now it is our choice. Either we have to go to C or we have to go to A. So here the sense of or is there. Leaving B, we have to leave the B. But everyone takes their choice. Either they go to C or they go to A. So here total ways are what? 4 plus 4. Or sense is here. So here the rule of addition will be counted. Here this one is towards C suppose, and this one is towards A suppose. So these are how many? Total 8 ways are there. Fine. Now let us write the notes on this one also, just like this. Now here the multiplication rule implies and or the condition. Here the options and here the conditions. Fine. And the another one, For multiplication events, for multiplication rule, the events should be what? Independent. They must be different. They won't be same. Fine. So let us write down the notes for that. Hopes you will understand it well. Now note first one, multiplication means and or condition, and or what? Condition. Okay. And the second note is that for multiplication events should be independent. Events should be independent. Fine. One more note is here. If between two processes, order is possible, then it will be considered by itself. It will be considered by itself in multiplication. It will be considered by itself in multiplication. We no need to do for that separately. It will be considered there. Now, for this, let me take example. Suppose there is a box having 4 objects, T1, T2, T3 and T4. Now suppose we have to draw 2 objects from them, but one by one. So number of ways of drawing, I must write the question. Number of ways of drawing 2 objects one by one, by or 2 objects one by one, and order matters. Suppose order matters. Then now number of ways of drawing first object, that is, now these are 2 different things. One by one means what? Firstly we will draw one object. There are 4 choices, so any one can be drawn. Now, but whenever we draw it second time, then there are only 3 choices. So number of drawing first object, into number of drawing second object. So it will be 4 into 3, that will be how much? 12. Now this is independent here. Now if we have to draw, or if we have to draw these, but order doesn't matter, suppose. Now actually here number of ways of drawing 2 objects only. That time it will be 12 by 2. That is what? 6. Now why does this? Now let us see, because here it is not mentioned that order matters. So if order doesn't matter, then the same thing will be repeat. Look at here. Suppose I got T1, T2. Suppose T1, T3. Then T1, T4. Suppose T2, T1. Means firstly I got T1, secondly I got T2. Firstly I got T1, secondly T3. Suppose T2, T3. Again T2, T4. Then suppose T3, T1. T3, T2. T3, T4. T4, T1. T4, T2. Then T4, T3. Now if you look it carefully, now here T1, T2 is same as T2, T1. Order doesn't matter. T1, T2 is same as T2, T1 that time. T1, T3 is same as T3, T1. Again T1, T4 is same as T4, T1. T2, it will be taken. T2, T3 is same as T3, T2. T2, T4 will be same as what? T4, T2. So how many are left? 1, 2, 3, 4, 5 and 6. These are, look at, T3, T4 are same. So 6. Only 6 possibilities in that case. So this is the explanation for this one. So here if multiplication is considered, then here if order is possible or order matters, that time it will be taken there. And here if order doesn't matter, then that time also it will be included. So we have to remove that. Fine. Now lastly, let me take one more rule, that is bijection rule. Simply I will write the statement of it and I will stop. I will explain the example of it will later on. Okay, we will stop here. We will take that example also in next video. Thank you.